Hello, I have had some requests on showing my collection of new magnets. Well, here it is. First, I will just quickly show you my smaller magnets, and later, to make this video more interesting, I will compare the powers in my larger magnets. What you see is a 135 cm long neodymium magnet made of smaller magnets in grade N45 or N52. Most of it was made of this stack of magnets. I also have a lot of geomags, some new magnets from an old hard disk drive, 5 1-inch ball magnets, and 11 20mm cubes. But now, let's bring out the big ones and test them. Okay, I'm ready now. In this test, I will determine at what distance the magnets will bend the tip of this jacksaw by 3 cm. To the left, you see the tip of the saw and a wooden stopper set at 3 cm from the saw. In the lower right corner, you see the size of the magnet being tested. I will simply slide the magnet closer to the saw until the tip is just touching the stopper, and read the distance between the magnet and the starting point for the saw tip when it was at rest. Not exactly a lab-controlled scientific test, but it should give an indication of the power of each magnet. The distance for this N45 magnet was 104 mm. And now we move into the finals, the 3 most powerful magnets in this test. And the winner is the magnet I have named the Mothership. Not surprisingly, the conclusion of this test is that if you need a magnet to work on a large metal object at distance, you need a big magnet. After all, the pull force follows the inverse square law. Double the distance and you need 4 times more force. Don't worry too much about the grade of the magnet. The magnet with the weakest grade in this test, N38, finished at 4th place, simply because of size. But what if you need to work on a small metal object like this paperclip? Is size still the most important factor? To test this, I will simply measure how much force in grams it takes to pull the paperclip off the magnets. Off camera, I tested it at least 10 times with each magnet with my head in front of the scale, until I found the average max pull for each magnet. I will quickly show you clips with the different magnets. Notice how similar the magnets perform, although they have very different sizes. The conclusion of this test is that size still matters, but it is no longer the most important factor. Actually, my fourth largest magnet was the weakest in this comparison. The most important factor when acting upon a small object is how concentrated the magnet is, known as the grade of the magnet. So, size and grade are factors that determine the pull force of a magnet. But shape can also affect the pull force. Take a look at these two magnets. They have the same volume, but the cube magnet has higher grade, so it should easily win based on what I have shown so far. But no, the ball magnet is stronger with a small object because its shape concentrates the flux to a small area. Let me sum it all up. If you need a magnet for heavy lifting of large objects and maybe at some distance, you should focus on size instead of grade. The gain with a higher grade is small compared with the higher price. For small objects at close distance, you should focus on high grade and even shape of magnet. The gain with a larger size is small compared with the higher price.